So yeah, good morning, everyone, or should I say good afternoon, because I think it's past 12, right? So a warm welcome to this webinar on the power of data analytics and AI for positive change as part of the Smart Nation Together initiative. Thank you all for joining me today. Wow, I think that's a lot of people, 100 plus participants. Thank you all for taking out the time to be here. My name is Subhayan Mukerjee, as Ivan so nicely introduced me. I'm an assistant prof at NUS. Before I get started with the content of my talk, let me first give a brief background about who I am and where I come from, right? So I have a background in computer science and mathematics, after which I worked in the industry in software and data analytics. And after that, I chose to pursue my graduate studies in the US. I did my PhD in communication from the University of Pennsylvania. And then currently, I am an assistant professor at NUS and a principal investigator at the Center for Trusted Internet and Community. So as part of my job, I do research at in digital media, online audiences, social media, right? And I teach courses in data communication and quantitative methods to a variety of students at different levels, from undergraduate to master's to PhD. All right, so we see a lot of news, a lot of talk about AI every day these days, right? Not just newspapers, but also think tanks like Brookings Institute at the top left, as you see on the screen. There's a lot of talk about how AI will change the world, how we must adapt. A lot of talk about how AI can, destroy humanity. A lot of talk about how AI will revolutionize the way we live our lives. And a lot of it is driven by the fact that the modern world is awash in data. And I mean digital data, not like analog data, not books and newspapers, not physical books and newspapers, but digital data, right? So let me set the stage for this talk by kind of asking this question. I'm not expecting an answer from you. Just think about it, right? How much data do you think exists in the world today, right? So before I give the answer, let me tease you with a benchmark, a comparison. So that is the amount of data you see on the graph, 2 petabytes. Don't worry about what a petabyte is. It's a very big number. So that is the amount of data that exists in all US academic libraries combined, right? So the US has hundreds, maybe thousands of universities, and each of those universities have a library, right? And so the 2 petabytes number you see on your screens is the total amount of data that exists in all those American academic libraries combined, right? But you will see that this is dwarfed by the amount of digital data generated globally every single hour, right? So on the left, you have all the information contained in all libraries in the US, academic libraries in the US together, right? Since university libraries began. And on the right, you see the amount of digital data being generated every hour globally, right? That's around more than 40 petabytes. So, and to kind of put a number to this amount of data that exists in the world today, let's look at this slide, right? So the total number of digital data in the world in 2020 was estimated to be about 64 zettabytes. Now, you probably don't know what a zettabyte is. We tend to think of in bytes and kilobytes, megabytes, maybe gigabytes. So let me try to put it in numbers, how many bytes that amounts to, right? So 64 zettabytes is 64 followed by 3, 6, 9, 12, 15, 18, 21 zeros, right? And even if you know nothing about data, about what a byte is, about anything about AI or machine learning or whatever fancy words you might have heard in this domain, you can get a sense of how massive the amount of data set we have in the world today. So the bottom line is that we have all this data in the world and we need to somehow make sense of it. And that's where data analytics and AI come in, right? So again, before I talk about AI specifically, let me show you another graph, which is called the Gartner hype cycle, right? I would introduce you to this idea developed and branded by the American IT consulting firm Gartner about the adoption and integration of new, often disruptive technologies within society. All right. So on the x-axis, you have time. On the y-axis, you have the visibility of a technology, right? So the graph starts off when a new technology is unveiled to the public. That's the technology trigger. And following the technology trigger, there is a sudden increase in the visibility of that piece of technology. You can call it hype, right? And it eventually reaches a peak of inflated expectations, where you'll see this technology being talked about everywhere, you'll hear about it everywhere, right? You might get tired of hearing about it everywhere. And that's when people begin to harbor some false expectations of what this technology can do, right? You'll hear all these huge promises about how this technology will change the world, how it will solve global poverty, how it will solve food shortages, a lot of things, right? And then after you've reached the peak of inflated expectations, people start to begin to realize that maybe the technology isn't as promising as the hype had said it would be, right? So people start losing interest in it, and it starts becoming less visible. And over time, it precipitously falls into this, what is known as the trough of disillusionment, where people realize that the technology that had been hyped up so much doesn't really live up to its inflated expectations. And people are disillusioned with it, right? Think of all the news we hear about social media destroying democracy, social media ruining the world, about computers taking jobs that happened when computers first came in the 70s and 80s, and so on, right? But those who tinker with the technology for long enough, those who stick around for long enough, those who see the technology past this peak of inflated expectation and past the trough of disillusionment, they begin to realize that maybe technology can be useful, if not in ways that was originally promised, not in ways it originally hyped, but it can help us do certain things in our lives. It can help us achieve certain goals better, maybe easier than what it would take before the technology came in, right? And that's what is called the slope of enlightenment. And following that, you reach the plateau of productivity, where the technology is well integrated with the society, and we use it in our everyday lives. And while it has not really, revolutionized everything like people had hoped it would, it had certainly made certain aspects of our life a bit more easier, a bit more streamlined, and it has become useful in an incremental manner. Right? Okay, so I'm going to start off here with this backdrop, right? So let me show you what the outline of this webinar will be like. So first, it will be the introduction, which I've already passed. Then I'm going to give you some definitions of what we mean by AI and some related terms. Next, we shall explore some case studies where AI has successfully been applied to several real-world domains: healthcare, education, and transportation, or urban mobility. Next, I shall talk about the skills you need to become an AI practitioner or a data analytics person. Before we delve into the ethics of AI, right? One shouldn't forget about that at all. And then finally, I will wrap up the webinar with the conclusion section, right? All right, so let's get started. What is AI? Now, I'm going to use a definition from the Infocom Media Development Authority of Singapore, where they define AI as the study and use of intelligent machines to mimic human action and thought. Another definition from the NUS School of Computing is that AI aims to build intelligent machines that can mimic human cognitive functions, such as seeing, learning, and problem solving, right? So it gets a bit more specific than just mimicking human cognition and thought. AI is specifically trying to do specific things that human beings do every day: seeing, learning, problem solving, right? So there's also the closely related terms of machine learning and deep learning. So machine learning was defined in the 1950s by the AI pioneer Arthur Samuel as a subfield of artificial intelligence, the field of study that gives computers the ability to learn without being explicitly programmed, And next you have deep learning, which is a set of methods within machine learning and artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. Now, all of these are very, they're extremely interrelated to each other, right? You will find various other definitions of these three terms, right? And most of them will, maybe they'll largely talk about the same, they'll define it in largely the same terms, but they might use slightly different words and slightly different kind of phrases. However, the definition that I'm most comfortable with is, AI, and then machine learning as a subset of AI, and deep learning as a subset within both machine learning and AI, that works in a way that is inspired by the human brain, right? Okay, so last set of definitions, data analytics, which is really the science underlying all of this, underlying AI, machine learning, and deep learning, is the science of analyzing raw data by inspecting, cleansing, and transforming information for the end user. It reveals trends and metrics so the user can make optimal business decisions and improve the system. Another definition by the NUS School of Continuing and Lifelong Education is that data and business analytics involve collecting, cleansing, transforming, and modeling data to draw out valuable insights for decision making. Right now, that's a lot of definitions, a lot of word salads everywhere. I don't like that myself, so I'm going to go into some more explanations about how AI works instead of just throwing definitions at you. Right? So, how does an AI model work? Right? So, imagine you're a robot. So that's a robot with like an AI brain. And you're tasked with recognizing animals. Say you're tasked with recognizing dogs, right? So AI machine learning models do that, right? So how would you go about doing it? So as a robot with an AI brain, you can see and listen to the world around you, right? And you see these things moving around you when you're observing the world, right? You don't know what they are. There are these weird shapes, four-legged creatures. Actually, you probably don't even know what legs mean, what creatures mean. You just see these shapes moving around. And whenever you see this thing moving around, there is a high possibility of you also hearing the word dog, all right? So you begin to realize that every time you hear the word dog, or you hear the sound dog, you see something like that, like those pictures you see moving around you, right? You don't know what they are, but if you look enough, if you observe enough instances, if you look at enough instances of these things moving around you and hearing the word dog every time you see these things, or not every time, most of the time you see these things, you begin to get a sense of maybe there is something common to these things you're seeing, right? Again, we as humans know that not all dogs are the same. Dogs are extremely diverse, but they have some similarities, right? They have four legs. They walk on four legs. They have 2 ears. They have 2 eyes, and they are often accompanied by humans, and so on. And you begin to distill the similarities across these observations, and you say maybe the word dog refers to these things these features that are common to these things that are moving around me, right? And so you begin to realize that there may be an association between the word dog and the construct that you are seeing moving around you, right? Again, all dogs are different. So depending on how much of dogs you have seen around you, you realize that not every dog is the same, but they all encapsulate some similarities across these moving objects, right? And that is really how an AI model works, right? Given all this data that it sees and hears, it begins to associate disparate elements with each other, disparate concepts to each other, right? And it begins to come up with these rules. And so it begins to learn what the sound dog means, right? So an AI model is essentially a mathematical relationship that a computer program infers by systematically looking at lots of data and following some rules. So don't think of this as a technical introduction to AI. This clearly isn't, and it's too complex an idea to convey in a single webinar like this, but I hope you get the intuition behind it. You look at a lot of data, the computer looks at a lot of data, and it begins to find some rules that help it to make sense of the data. And there are two steps to building an AI model. The first is training a model, where the model is fed lots of data. Think of the robot seeing dogs and hearing the word dog lots of times, right? And then it identifies patterns in this data set called this data set, which is the training data set, right? And then the model is tested on new data. So you have trained the model using lots of pictures of dogs and sounds of the word dog. And then you're testing the model by giving it a picture and asking it, is this dog or not a dog, right? And so if it passes the test, well and good, it's not a single test, it's lots of tests. So maybe like you give it 500 more pictures of dogs and sees whether it can identify at least 450 of them. But if it doesn't, if it cannot identify enough dogs correctly in the testing phase, you go back to the training phase and train it again with better data. And so this is essentially an iterative process. You train and test till your model passes some test benchmarks like accuracy, right? For example, you want it to be 90% accurate in identifying dogs, or 95%, depending on your use case. Okay, so now that's a very bird's eye view of how AI models work. Now let's try to think of why we need AI. How can AI help us in our daily lives? So the first application of AI and data analytics in general lies in enhanced decision making. So AI and data analytics enable evidence-based decision making by providing accurate and timely insights derived from data. This leads to more informed choices, reduced risks, and improved outcomes. Think of something like cancer detection, right? We know that AI, if you haven't, you check it out. I'll also talk about it later today. AI models have been shown to be far more accurate at detecting cancer than human doctors are. Next, we have resource optimization. So by analyzing patterns and trends in data, organizations can optimize resource allocation, reducing costs and maximizing efficiency. This includes workforce optimization, inventory management, and even the utilization of equipment and infrastructure, right? So these may seem very high level right now, but I'm going to give you some examples from the real world where I'm going to help you understand how AI lets you achieve these goals. And then you have prediction, which is arguably AI's biggest feather in the cap. So data analytics and AI allow organizations to predict future outcomes and anticipate trends. This facilitates proactive planning, risk mitigation, even strategic decision-making based on data-driven insights. Next, you have automation and efficiency. So AI-powered automation streamlines processes, reduces manual effort, and increases operational efficiency. It enables tasks to be performed faster, with fewer errors, and even frees up human resources for potentially more complex and creative endeavors that humans are better at. And then arguably the other feather in the cap that AI has and that we encounter every day in our lives whenever we open social media platforms like an app is personalization. So you leverage data and AI, organizations can deliver personalized experience, services, and products tailored to individual preferences. Think of online shopping, right? You see ads on Instagram and Facebook and TikTok that are very relevant to the kind of things that you care about, that you want, right? And that's possible because of these models. This enhances customer satisfaction, engagement, and loyalty by providing relevant and targeted offerings. And finally, you have competitive advantage. So data analytics and AI offer a significant competitive advantage in today's digital landscape. So organizations that harness the power of these technologies can gain insights better than their competitors, identify new opportunities before their competitors, and respond quickly to market dynamics, thereby staying ahead of the competition. All right, so let's talk about some of these real-world applications, right? So we'll first focus on healthcare, which arguably we all think is a worthwhile domain to focus on. The first example I'm going to give is Mirai, which is the breast cancer prediction tool developed by MIT researchers. Now, the great thing about Mirai is that it's an AI model that's trained on over 200,000 clinical exams for breast cancer, and it's significantly more accurate than other methods at predicting cancer risk and identifying high-risk patients. And one of the great things about Mirai is that it's trained on diverse data sets, right? So it's trained and validated on American, European, and Asian data. So it's equally accurate at predicting cancer risk across these different human populations. And we shall talk about what happens when your data set isn't diverse enough in the ethics section. So hang on to that. All right. Then we have another really groundbreaking application of AI in healthcare, which is known as STAR, Smart Tissue Autonomous Robot. So STAR, developed by researchers at Johns Hopkins, is the first robotic system to plan, adapt, and execute soft tissue surgery with minimal human intervention. Right? So remember, I mentioned automation being one of the key applications of AI. So here's a great example in a very, very important context, right? That many of us are often that we need, right? So STAR is essentially an AI-based tracking algorithm that is trained on thousands of motion profiles to predict tissue motion, right? So when you're cutting a tissue, when a surgeon is cutting a tissue, it knows exactly how much the tissue will move inside the body, right? And sorry for becoming a bit too maybe talking about like human insides of a human body, but it has really revolutionized how accurately surgeons can place sutures during surgeries, how they stitch tissues, and how they even adapt surgery plans if things go south, right? And so this shows that tasks that require high precision and repeatability can be performed with more accuracy, independent of surgeon skill. So this importantly democratizes the surgical approach where you are no longer dependent on having a very good surgeon to do your surgery, right? So irrespective of how good your surgeon, how good or how competent or not your surgeon is, using something like this, a model like this, ensures that the patient outcomes are more consistent across different hospitals and surgeons. Let's now talk about some initiatives in Singapore in the domain of healthcare. So how AI and data analytics helps is that it lets you personalize how you're treated. And it's similar to how we see our curated feeds on Instagram. It's a personalized feed. Similarly, AI can help personalize your treatment when you need it, right? So precision medicine research, which is a huge initiative, it's part of Singapore's strategic goal to use big data analytics on genetic, lifestyle, and clinical data to understand health outcomes of Singaporeans, is a great example of personalized treatments, right? So the IHIS, the Singapore's health tech agency, is driving this healthcare segment of Singapore's national AI strategy to harness technology and data to predict risk and severity of treatment outcomes, right? So there's a lot happening in Singapore using AI in healthcare. So feel free to check out those links at the bottom if you need to know more about, if you're interested in this field. All right, so next, let's talk about AI in education, which I'm sure all of you will agree is another very noble enterprise, right? Like healthcare. I'm sure thanks to maybe ChatGPT, most of you are aware of. So let me run a quick poll here, right? So how many of you have used or heard of ChatGPT or other LLMs? So here's a question, here's a poll. Please take a minute to answer. Okay, so I'll close the poll now in 2 seconds. All right, so you should be able to see the results of the poll now, right? So which is great. Most of you have heard of it. Some of you have used them a few times. Some of you, 16% of you use them regularly, which is pretty impressive. So yeah, I am one of those who uses them regularly for a lot of things, right? So now that I know that you have some knowledge of ChatGPT, I'm still going to define it a bit later, but essentially, models like ChatGPT, large language models like ChatGPT, have been, we hear a lot about, how they are undermining education by enabling plagiarism and all that, giving inaccurate information, but they're really also revolutionizing certain aspects of how we learn, right? So let's continue with the presentation. So you've all probably heard of Duolingo, right? The app you use to learn a new language. But did you know that Duolingo uses AI to create as well as score English proficiency tests? The way it works is that it develops test items based on a given standard. So you ask Duolingo the English test to come up with questions of either easy, medium, or hard, or extremely hard difficulty level. And it produces a set of test items that you can use for the test, right? And it reduces reliance on human labor, and it makes the creation of a test much more efficient. And on the other hand, it also obviates the need for expensive pilot tests using real students. So say you have a question yourself, and so you need to know how difficult the question is. And the Duolingo English test can help you assess the difficulty of the question without you having to trial the question among real students. And it's worked really, really well out in the wild. So it's pretty promising the way it's headed. The next example I'm going to give is that of Inquire. Inquire is an iPad app that is built by Stanford researchers. It combines the Life textbook, which is a pretty popular biology textbook used in the US, with a knowledge representation and reasoning system that answers students' questions about the material. So here's how it works. So it uses AI models to ask students questions about what they're reading and highlighting. So it helps students better engage with the text, right? So when you're reading a certain paragraph or you have maybe highlighted certain text, it instantly asks you questions about what you have highlighted and maybe even connects what you are currently reading with what you have read in the past, thereby allowing your engagement with the text to be much greater. And lastly, it also provides precise answers to free-form questions asked by the students, right? So you can just ask, define this, or how does this work? And instead of just, you having to look up the index of the textbook and knowing which page it is on, you can very easily, it'll direct you to wherever on the textbook the answer is and even summarize it for you using the text from the textbook, right? So that's another very promising development. Now, one of my favorite examples of AI application in education is Khan-Migo. I'm sure all of you have heard of Khan Academy. If you haven't, you should look up their videos, their resources. They're an excellent learning platform. So Khan-Migo, which basically means Khan and Amigo, is a great example of how AI can be effectively used in the education sector at a very large scale. So by analyzing patterns of how students engage with learning material, it allows a very high level of personalization beyond what teachers can do, right? So it uses student data to learn student learning patterns, and it also helps teachers plan their lessons. So Khan Academy markets it as a tutor for learners and an assistant for teachers. So, and more than anything, it shows how traditional AI or machine learning can be used in conjunction with LLMs like ChatGPT to make AI tutors more conversational. So here, you will see the use case from the student perspective. The student asks, can you just tell me the answer? But Khan-Migo replies, it's important that you learn how to do this yourself, right? So it basically walks the student through the learning process in a conversational manner. On the flip side, if you're a teacher looking to design lessons for a class that you will be teaching, it helps you as well. It asks you for your specific requirements and student background and provides you with or points you to the resources and material that you could use for this lesson. right? So in Singapore, the use of AI in education is one of the major national AI projects of the Smart Nation Initiative, right? So similar to CanMego, they are developing an adaptive learning and assessment tool, which will serve as a learning companion to enhance the learning experience for students at an individual level. All right. So let's now move on to our third domain, which is urban mobility or transportation. Now, the first example I'm going to give is kind of close to my heart, is that Siemens Mobility, the company, they designed this adaptive traffic monitoring system to address traffic jams in the Indian city and tech hub of Bengaluru, right? So Bengaluru is notorious for the traffic jams, and it uses computer vision AI models that are connected with the street cameras to detect vehicles on the road. It reduces the need for having police everywhere. And which, if you have been to India, you will know that you need traffic police everywhere to control the flow of traffic. And then these algorithms alter traffic lights based on real-time congestion data, which they get from the camera data. And then they allow the traffic to be moving they allow traffic to move more efficiently by reducing wait times and so on, and make the, basically optimize the vehicular movement. And then another example is that of CertTrack, which is yet another adaptive traffic control technology developed by researchers at Carnegie Mellon University. It uses AI models to identify different kinds of vehicles at every intersection and comes up with the best solution to move traffic optimally through the intersection, right? And I think a lot of us in Singapore are kind of feel when we're walking on the road, when we're waiting for the lights to turn green so that we can cross the road, that there are not enough cars crossing the road. So why am I still waiting, right? Because there are no cars crossing in front of me. So why can't the light just turn green for me, right? And so that's exactly the problem that CertTrack tries to solve. And it pretty successfully did solve that problem. And the company claims that this has reduced wait times in Pittsburgh by 40%, journey times within the city by 25%, and emissions by 20%, which is pretty impressive. Now let's talk about some initiatives in Singapore in the domain of transportation. So Singapore is obviously not behind in using AI for urban mobility. Of course, self-driving cars, an example I haven't given yet, but I will be coming back to this example in subsequent slides. We have heard of them by now. Were publicly trialed in Singapore by the NUS Smart Alliance, the Singapore MIT Alliance, back in 2014. Also, Asia's first fully operational vehicle, fully operational self-driving vehicle has been used to enhance connectivity within Gardens by the Bay here in Singapore. And finally, we have had driverless trucks being trialed on Jurong Island since 2017. Right? So now we have looked at lots of examples of how AI can be used in the real world domains, both internationally as well as in Singapore. So you might be wondering what skills you need to get into this sector. So this takes me to the next section. So to do anything useful in data analytics and AI, you need to know how to code. There is no two ways about it. Yes, no code solutions are increasingly popular these days. And yes, again, thanks to AI, many of them work very well. But to do anything effective in this field, you will still need to know the basics of programming and be able to understand how code works, even if you are not writing as much code as you probably would be required to write even 5 years ago. Then you need to be mathematically and statistically literate. By this, I don't mean that you need to be a math whiz and solve math problems all day, but you do need to be able to understand the basics of linear algebra, calculus, probability theory, and statistics. Indeed, a lot of bad application of AI and technology in general stems from ignorance of statistics. Next, and this is perhaps the most important, you need to be able to understand machine learning and deep learning concepts. I mean, not just generic problems of machine learning, such as regression, prediction, and classification, but also the technical details of, say, how neural networks work. Even if you may not be required to know them at a very deep fundamental level, you'll still need to be able to talk about how it works, right? You should be able to understand when you read something about neural networks and so on. You'd also need to be competent with machine learning frameworks such as TensorFlow, PyTorch, Keras, and so on. So now you have built your model and you have great results, and you need to be able to convince your company to roll out your product. For that, you need to be able to visualize and handle data. Now, data handling can also be considered a pre-processing step before the machine learning and modeling steps. But essentially, you need to be able to slice, dice, chunk, chop big data sets, create visualizations, and communicate them using dashboards and graphs to relevant stakeholders. This is often a public-facing side of this whole enterprise, but it is often as fundamental to the data analytics ecosystem as any of the others. And next is a more generic skill, that of problem solving. So critically being able to think about a problem and coming with a creative analytical solution is extremely important if you're in this field. Because the problem you will face in this line of work won't be problems you have probably faced before, you need to find solutions and think deeply about the ramifications of your solutions, weigh the pros and cons of different solutions and decide what to use. This often entails, and this is extremely important, picking up new skills every day to solve a problem at hand. And this is something that every data scientist, a machine learning engineer, or an AI programmer has done at various points during their career and their jobs. So learning doesn't stop if you're in this business, or to be fair, in technology more generally, right? So 20 years ago, Microsoft Excel was a cool skill to have if you were trying to get into technology. If you were getting into data, not anymore. You need to keep moving with the times and keep adapting to the state of the art. And finally, all of this is of no use if you don't have the right domain knowledge. Are you working in healthcare? You better know the ins and outs of how your product may affect the healthcare industry and how it may affect healthcare providers. Same with education, right? You need to get a good grip on pedagogy, student psychology, and so on. Now, domain knowledge is extremely important for the responsible application of AI in the real world. Now here, I'm going to take a break from my narrative and tell you all very briefly about our Masters in Social Science Communication program. If you're interested in getting started in this field of data analytics, which is really the first step you need to take in order to enter the AI world, consider applying. Financial assistance is available. So we have a dedicated data communication track where you can learn things like coding for communicators, social media analytics, audience analytics, and visualizing data. I teach some of these courses myself. There is financial assistance available for ASEAN students, Singapore citizens and PRs, and NUS alumni. All right, so please scan the QR code if you're interested to know more about this program, and I hope to see some of you in my classes in the future. All right, that's enough self-promotion. Let's move on to what is unarguably the one can say the most important aspect of AI. That is the ethics of AI. Now, let's talk about bias and discrimination, because that's really the first thing that comes to mind when you hear about ethics in the context of AI. So we have seen, the fundamental idea is that biased data can lead to biased predictions, and biased predictions can lead to discrimination and marginalization. We have seen several shocking examples of AI models being biased or discriminatory, often inadvertently. Right? So for example, what if the training data was skewed in favor of a specific group, say gender, or a specific gender, or a specific ethnicity, or say neurotypical people, and did not represent others from other genders, other ethnicities, and say neuroatypical people? Would an AI model be able to predict health outcomes or be an effective pedagogical companion for those who were not represented in the training data? Probably not. Therefore, and this is key, the training data must necessarily be representative of those who will be affected by it. For a very simple example, think of self-driving cars and how they know who's a person on the road and must be avoided, right? So they use huge training data sets to learn what is a human. Now say these data sets are biased and only represent people of a certain skin color, or those wearing a certain attire, or those without glasses, and so on. Right? Now, if this self-driving car were to encounter one such person who is not represented in the training data on the road, it would probably not know that it's a human and must be avoided. And what happens as a result? The car will mow down the pedestrian, cause injuries, or worse, even kill them. This can be perceived by many to be dehumanizing, right? Because the car did not consider that person to be a human. Which is why we must ensure that training data sets represent the rich fabric of human diversity, or at the very least, represent the population of where it will be deployed. And then you have the concerns about privacy, transparency, and accountability. Now, datasets on which AI models are run can be very sensitive. What if they fall in wrong hands? So think of health records. And what if your insurance company decides to charge you higher premiums based on your supposed risk of getting a disease, which an AI model can do by looking at your health, your medical data? You don't want that to happen, right? You don't want the data to fall, the sensitive data to fall in the wrong hands. Next, can we trust an AI algorithm to make the right decision if we do not know how it has made the decision? Right? A lot of these AI models are unsupervised. They are trained without any human supervision. That's what makes them both powerful at scale and also potentially dangerous. So again, think of self-driving cars. What if a car had to choose between hitting a wall, which would kill the driver, and hitting a pedestrian, which would kill the pedestrian? This raises many deep philosophical questions of how much we can trust an AI algorithm to do the right thing. And finally, there is a question of accountability. Who is accountable for the decision made by an AI model? So say in the unfortunate event that an exceptionally reputable, accurate robot surgeon makes a mistake and causes harm to a patient, how can accountability be attributed? Do you blame the doctor who ordered its use or the robot? What do you mean by even blaming the robot, right? Do you sue the company that built the robot? Maybe, we don't know, right? These are questions for which answers are not very clear at the moment. Next, let's talk about the wider societal impacts of AI. And one which we keep hearing is about labor, about how AI is going to take your job. But that is only partially true, if not completely false. It's not AI, but a person using AI that is more likely to take your job, right? Which takes me back to the idea of lifelong learning and being able to adapt to the state of the art. You can, on the one hand, adapt and upskill yourself and stay abreast of the latest goings on in the world of technology, if you want to keep your job in the tech sector, or you can, blame AI, right? One of them is fruitful, the other is probably not that fruitful. Okay, sorry, maybe I should have put that text a bit earlier. All right, so next we'll talk about the last wider societal impact of AI, and this is perhaps not as well known, but training AI models isn't actually great for the planet. So I'll read these two quotes, right? In 2019, the University of Massachusetts Amherst researchers trained several large language models and found that training a single AI model can emit over 626,000 pounds of CO2, equivalent to the emissions of 5 cars over their lifetimes. That's a lot of CO2 for training a single model, right? A more recent study reported that training GPT-3, which is the precursor to the model being used in ChatGPT today, with 175 billion parameters, consumed 1,287 megawatt hours of electricity and resulted in carbon emissions of 502 metric tons of carbon, which is the equivalent of driving 112 gasoline-powered cars for an entire year. Now, that's a lot, whichever way you look at it. So while a lot of work today focuses on reducing the carbon footprint of the AI industry as a whole, in order to meaningfully impact society, AI must grapple with the question of climate change. Right? I'm now going to wrap up my webinar with a few concluding thoughts. Remember that AI isn't a shiny new toy. It can affect meaningful positive change, but only if you use it carefully. Here are some very high-level don'ts and do's when using AI. So remember that AI isn't the solution to everything. Don't get naively caught up in the AI hype. It's a useful set of tools that can potentially make some aspects of our lives easier at the cost of raising newer questions and concerns. And second, do not discard your ethics when designing, deploying AI models. And for some do's, do understand what AI can do and what it cannot do. Do be conscientious when using AI. And last, I cannot stress this highly enough, do invest in picking up the skills you need and keep learning. So I'm going to conclude with this slide again. I showed you this graph earlier on, the Gartner hype cycle. I want to show this again to warn you to not find yourself teetering on the peak of inflated expectations. That's never helpful. Also, do not wallow in the trough of disillusionment. That is not helpful either, right? Try to be on the slope of enlightenment and try to reach the plateau of productivity. Good things can happen in that, that yellow shaded region. I hope you all stay curious and keep learning. Thank you. With that,